let's begin here with the first example for binomial probability distribution. Now the question is, changes in pH can cause drugs to precipitate out of solution. A common example of pH affecting stability is with morphine sulfate. A research laboratory analyzed 100 vials of the drug. The possibility of this drug to precipitate is 1%. Now calculate the chance of observing 3 vials containing precipitate. Now first thing we have to do is to check whether this scenario here, this example, fulfill all the binomial probability distribution requirements. Now what is the first requirement? The procedure has a fixed number of trial. In this case, it does have a fixed number of trial, which is they are analyzing only 100 vials of the drug. So the n value here is 100. Next, the trial must be independent. What it means is the outcome of any individual trial does not affect the probabilities in the other trial. Okay, in this case, this trial is independent. What it means is that if you pick one trial, which is picking of one vial which is non-precipitated, is not affecting the results of the other vial. Now each trial must have all outcome classified into 2 categories. That's the third requirement. In this case, you can either pick a vial which is precipitated or which is not precipitated. So in this case, there's 2 categories. So the outcome is dichotomous. Alright. And the fourth requirement is that the probability of success remain the same in all trials, which is true in this case. So if you get the possibility of precipitate remains 1% throughout the entire trial. What it means is probability of P getting a success of precipitate is 0.01. This is from the 1%. Now the possibility of getting vials which is not precipitated, which is Q, equals to 0.99. So in this case, all the requirements for the binomial distribution has been fulfilled. Now what you have to do next is to identify what the N, P and Q values are. As I mentioned earlier, the N is the fixed number of trial, which is 100 vials, so N equals to 100. P, the success of getting a precipitated vial, is 0.01. Meanwhile Q, to get vials which is not precipitated, is 99% or 0.99. In this case, X will be 3. This is what we're interested to see, to observe 3 vials containing the precipitate. So what we have to do next is to insert those values. P equals 0.01, Q equals to 0.99, N equals to 100, and X equals to 3 into the binomial probability formula as given here. Okay, so once you insert those values, you can use your calculator and calculate, and this is factorial. Okay, N factorial over N in this case is 100 minus X3, and then close bracket factorial again, and then we have X factorial, which is 3 factorial, P power of X. In this case, P is 0.01, power of X here is 3, multiplied by Q, which is 0.99, to the power of N minus X. In this case is 100 minus 3. So this is what we got. Now putting in all those values, we will get the answer. The probability of observing 3 vials with precipitate is 0.0610.